Hi, welcome back to edquest. Today we will discuss PVC setup with local path provisioner. Now that our Kubernetes cluster is ready, let's talk about PVC setup. Kubeflow heavily depends on the persistent volumes, especially for the services like min.io, metadata, and the pipelines. These components need a reliable way to store and retrieve data even when pods restart. To handle this, we will use something called local path provisioner. It allows Kubernetes to dynamically allocate storage from a local disk path on the node. This is a lightweight and efficient solution, especially suited for local cluster or testing environments. It helps us avoid the complexity of setting up external storage backends. Now we will do the practical workshop where we will see how to set up Kubeflow pipelines and the local path provisioner. Let me go to the terminal first and I will show you my readme file, and I will copy all the commands from readme and paste in terminal and execute one by one. This video will take more than expected time. We will pause in between whenever the processing happens at the backend. Yeah, let me go to the terminal first. So here you can see this is the terminal which I am using, and let me clear it first. And the IP of this node machine is 192.168.1.100. This machine is available into my local environment or the local network. That's why this machine or the node is saying its IP is starting with 192. And so this is the GitHub repository available to you. You can take a look, and the same link is available into the video's description. Here we describe all the steps, overview, prerequisites, and why we need to set up the PVC. We are explaining each and every step with the specific commands like create manifest directory, create provisioner YAML files, apply provisioner YAMLs, and so on. We have multiple sections here with the multiple steps. Total we have around 18 steps. We will go one by one, and I am coming to the section 1, PVC setup with local path provisioner. To execute it, before going into this part, we will check our Kubernetes is working fine or not. To check the Kubernetes, I will run a command kubectl get po -a. And you can see these are the kube systems available, and the components are available for the Kubernetes, and all are in running status. And this column will tell us about when it is restarted, and this will tell us what is the age of this. So in my node, this part of services etcd and the API server, these things are running from last 12 days, and something like the ice cream model deployment is running from last 24 hours. Now I'm going back to the readme file of my repository, and I will create or copy this command and go back to the terminal and paste here. Just pressing enter, it will create a directory. Okay, to show this is created or not, what we can do, we can write a command ls and then paste this part. To check that directory is created or not, we can write a ls command with this directory path. I am pressing enter here, so it is saying local path provisioner is available. Going back to the readme file, and it is saying creates a folder to store the local path provisioner YAML definition files. Now our next step is to create the provisioner YAML file. First of all, we will create the provisioner YAML file, and then we will pick the YAML file code from the local provisioner. I am opening it in the separate tab. You can go into the next tab, and this is the path, and we have to just copy all the content from here and paste in the file created by us in previous step. So to create the file, I am using Nano. It's up to you. You can use Nano, else you can use the VI or other editor in which you are more comfortable. So I am just copying this command, going to the terminal, pressing enter. Okay, so I am using VI instead of Nano. So that's why I just updated this command and pressing enter here, and I am pressing I to insert. It's ready to insert the content. Going back to the GitHub repository, going into the local provisioning, and inside the local provisioning we have the local path storage YAML file. We can copy it from this icon, and we can go back to the terminal and paste here. Okay, so all the code is available into the file. To save this file, I am pressing escape :WQ and then enter. My file is ready with all the code available into the GitHub. So we can go back to the readme file, and we can execute our next step. To execute the next step, we have to execute the kubectl apply command, where we are giving a path of the YAML file which we just created in the previous step. So just directly copying this command from here, going back to the terminal, pasting here, pressing enter simply. So it is applied, and it is scaling up all the binaries and the required dependencies. Now I will show you the pods running at the backend by executing the same command which we executed previously. So the command is kubectl get po -a. I misspelled it. It's kubectl get po -a. So as you can see the output of the get po command, so you can clearly see local path storage namespace is clearly available, and the name of this pod is the local path provisioner with this random generated ID, and the status of this pod is running, and it restarted 0 minute ago, and we can say the age of this pod is 59 seconds. Okay, so to execute the next step, I am going back to the GitHub repository readme file, and the next step is to make the storage class default. To execute this step, we have to copy this command, go back to the terminal again, and then just paste. Then we can simply press the enter. It will help us, and it will clearly show you the message storage class.storage.k8s io local path passed. Now our path is passed. Our next step is to verify the storage class. Is it available or not? To verify, we will execute this command. I am just copying simply and going back to the terminal and pasting here, pressing enter. It is showing like local path default is available and provisional is rancher.io local path. Okay, and our 8th step is to ensure host directory exists or not. To check to execute these commands, I am again simply copying. In our next step, we will ensure the host directory is created in our previous steps or not. If that is not created, you can simply execute this command, and before executing this command, you have to check if this directory is already available into the system. You can just ignore this command, and after the next step is to change the access mode of this directory. So we have to change, I am giving you read and write all the permissions to this directory. That's why I am giving the 777 access code and executing this command. into the terminal. It is executed successfully. So we can ensure successful volume creation by provisioner. Now next section is to Kubeflow pipeline deployment. To execute or to deploy the Kubeflow pipeline, we have to download Kubeflow manifests. To download the Kubeflow manifest, what we will do, we will create a directory at the root level. The directory name will be Kubeflow, and then we will go inside this directory and we will execute the wget command to download from the official repository, GitHub repository of the Kubeflow. So I am just going into this directory first because it is already created in my node, pressing enter and then executing the wget command to download the tar file. So it will take couple of minutes. No, it is downloaded directly. Our next step is to extract the tar file. To extract the tar file, I am using the tar xgbf and then file name. xgbf will help us to extract or the untar this tar file. Now I am executing the ls command to show you how many files or YAML files we have in it. So you can see there are, one is the tar file and this is the manifest file and this is the local path provisioner. Okay, going back to the readme of the GitHub repository. Now this manifest 1.6.1 will give access to the directory which contains customized based YAML files for all Kubeflow components. Now our next step is to remove the GCP inverse proxy. To reverse or to remove the GCP inverse proxy, we have to execute this command in same directory. So I just copy it and paste it here. So it will remove the GCP inverse proxy. Ensure that only required components for on-prem installations are applied. If you are working on the public cloud. Now our next step is to create the Kubeflow namespace. To create the Kubeflow namespace, we have to copy this command, go back to the terminal, paste here and then just simply press enter. Our namespace is created. All Kubeflow components will be deployed inside this namespace. Now what we have to do, we have to go into this manifest 1.6.1 directory and then execute the Kubeflow apply command. So let me copy these commands one by one, pressing enter, copying next command, which is the kubectl apply -k and then the scoped resources. It gives you the instant output and execute it quickly. Now we can wait for CRDs to be established. To wait, we have to execute the kubectl wait for conditional. For wait condition established, timeout 60 seconds we can pass, or you can customize this time according to your convenience. So I'm just copying it and passing it the 60 seconds for my convenience and pressing enter. It executed. Now apply Kubeflow pipeline manifests. To apply this, simply you can copy this command and go back to the terminal and execute it. So it may take a couple of seconds according to your system's performance. For me it is executed already. So I am switching my tab in this and you will see the pods are running because I executed here the watch command, and here we can see these are the namespace available and these are the names, and here we can see the ready, status and restarted and age. So you can see here the namespace of Kubeflow is already available, and inside this namespace we can see multiple pods are running and those are running and functional state. Yeah, I'm coming back to the readme file. So if in your scenario all these pods are not in running state, it's in different state, then you have to wait. But in my scenario, all the pods with namespace Kubeflow are in running state now. So according to your system's performance, you can take a look and you can go for the next step. Our next step is patch pipeline UI as node port. Before going into next step, I am opening a different terminal and executing a kubectl get svc command. This will help us to show you the service available under Kubeflow namespace. So I'm pressing enter and you can clearly see this ML pipeline UI service is available, and this is available at the cluster IP 10.105.176.145 and the port is 80, and we can hit it and we can see in the browser. Okay, I'm coming back to the previous terminal and going to the readme file and copying this code to patch pipeline UI as node port. So change the ML pipeline UI service type from cluster IP to node port as per your convenience. In my scenario, I am using the 31380 port to execute the UI, and we can access the same UI via the browser as well. So I'm pressing enter after pasting all this thing which we copied from the GitHub readme file, and it is saying service ML pipeline UI is patched. And you can go back and re-execute the same command and you can see the ML pipeline UI node port is patched now. Now what we will do, we will do the node IP, we will update the node IP, and colon 31380 port is same in my scenario. I can go to the browser and paste here, and the IP we have to pick it from and the node IP which is we have to provide. In my scenario it is 192.168.1.100. So we can see the Kubeflow pipeline user interface is working fine, and we can see these are the pipelines available into the kubectl or the Kubeflow. And our next step is this is also done. Now we have to verify the deployment. Is it deployment done successfully or not? To check or to verify these things, we can execute these commands one by one, and I'm just copying it, going back to the previous terminal, pasting here, pressing enter. It will show you this thing is running and working fine. All these things are created 6 or 7 minutes ago, which we created in this video session only. To execute the svc, to fetch the svc information or the service information, we can execute the command kubectl get svc -n kubeflow. So it will tell us the visualization server or the node port ML pipeline UI is available and it's ready, and it's running onto the 31380 port. Yeah, this was it. So this is the way how we can execute and set up our Kubeflow environment. So as we completed the Kubeflow installation, we completed the provisioner and we enable dynamic PVC provisioning using the local storage, and we downloaded Kubeflow 1.6.1 version manifests, and we remove the GCP inverse proxy part. All those things which we discussed into the agenda we completed successfully, and I am wrapping this session. In the next session we will give you a walkthrough of the Kubeflow interface which is available into the same IP and port. I will explain you about the pipelines, experiments, runs, and all the components available into the Kubeflow user interface. Thank you for watching.